Hello everyone, I am Prakriti and from Sri Venkateshwara College of Engineering. So today I am going to present about end-to-end machine learning projects which comes under the subject called machine learning. Uh, so embarking on an end-to-end machine learning project is an exciting that offers the potential to solve complex problems and derive impactful business decisions. This comprehensive guide will equip with the knowledge and tools to navigate the entire machine learning life cycle, from defining the problem statement to developing and monitoring your model. Defining the problem statement, so clear objectives. Start by outlining specific, measurable, achievable, relevant and time bound objectives. So these objectives will guide your project and provide a clear roadmap for success. So target audience, identify the intended users of your machine learning solution. So this will shape your model's output and ensure it meets the needs of its target audience. So data availability assesses the availability and quality of data relevant to your problem. Data availability will significantly impact your model's performance and may require data collection strategies. Constraints, acknowledge any limitations or constraints such as time, resources or ethical considerations that may considerations that may influence your project's directions. Data collection and pre-processing. So data acquisition, gather data from various sources including databases, applications, scraping and or public data sets. Ensure the data is relevant and conforms to the problem statement. Data cleaning, identify and handle missing values, outliers and inconsistent data entries and duplicates. This step ensures data these duplicates and these steps ensures the data quality and integrity. Data transformation, data splitting. So data transformation is nothing but transforming the data into a suitable format for machine learning algorithms. So this involves normalization, standardizations or feature scaling. So data splitting is divide the cleaned data set into training, validation and test sets to evaluate your model's performance and prevent out overfitting. Feature engineering and selection. So feature extraction, transform raw data into meaningful features that capture relevant information for your model. So this model can involve creating new features from existing ones or using domain enterprises. And feature selection is identifying prioritize features that contribute to most of the model's performance. So this involves using techniques like feature importance, correlation analysis or statistical test. So feature scaling, scale features tend to a common range to prevent certain algorithms from being based by features with vastly different scales. Common methods include min-max scaling or standardization. So dimensionally reduction. So reduce the number of lectures while preserving as much as information as possible. Techniques like principal component analysis or linear discriminant analysis can be applied. Model selection and training. So first you have to choose an appropriate machine learning model based on problem type. So data characteristics and the desired outcomes. So common model types include linear regression, logistic regression, decision trees, and support vector machines and neural networks. So model training is you have to train your chosen model using the training data. This involves adjusting the model's parameters to minimize errors and optimize its performance. So model evaluation: evaluate the trained model's performance using the validation data, assesses metrics such as accuracy, precision, recall, F1 score, or mean squared method. Model evaluation and validation. So evaluation metrics. Evaluation metrics accuracy. So this the proportion correctly classified instance. So precision is the portion of positives among all instance predicted as positive. So the recall, the proportion of true positive among all actual positive instance. So F1 score, the harmonic mean of precision and recall. So mean squared error, that is MSE, the average square difference between the predicted and actual values. Hyperparameter tuning and optimization. Grid search explore a predefined range of hyperparameter values and evaluate model performance for each combination. Random search randomly sample hyperparameter values from a specialized distribution and evaluate the performance. So Bayesian optimization use a probabilistic model to guide the search for optimal parameters, considering precision evaluations. Gradient descent iteratively updates hyperparameters based on the gradient of the model's performance metric. So model development and monitoring. So cloud deployment. Deploy your model to a cloud platform like AWS, Azure, or Google Cloud for scalability, availability, and cost effectiveness. Database integration. So integrate your model with the databases to store and retrieve data, enabling a seamless data flow and model updates. Application development, create an API to explore your model's functionality to other applications, allowing for seamless integration and access. Model monitoring, continuously track your model's performance, identify potential issues, and retrain it as needed to maintain optimal performance. Conclusion: building end-to-end machine learning projects require a structured approach from problem definition to deployment and monitoring. By following best practices, addressing challenges, and continually improving your models, you can unlock the full potential of machine learning to solve real-world problems and derive innovation. As the field continues to evolve, stay informed about emerging techniques and tools and ethical considerations to remain at the forefront of machine learning development.